Hi everybody, Mrs. Pesic here. We are looking at section 1.8, combinations of functions, and in particular also especially composite functions. So your learning objectives in this section are to add, subtract, multiply, and divide functions, and to find the composition of one function with another. You're also going to use combinations and compositions of functions to model and solve real-life problems. So two functions can be combined to form new functions. So for example, let's say f of x was x squared and g of x was 1 minus x. Can you find f plus g of x? Well, when you see this notation, that's the same thing as saying find f of x plus g of x. So in this case, you would just need to do f of x, which is x squared, and g of x, which is 1 minus x, and just add them together. Well, there are no like terms, but let's put it in standard form at least. So I'd have x squared minus x plus 1. And so this would be my answer for what is f plus g of x. Remember, we say f plus g of x, not f plus g times x. There's no multiplication going on here. Okay, so let's take a look at a subtraction. So for this one, f minus g of x is the same thing as saying f. Let's try that again. Same thing as saying f of x minus g of x, and in this case that would be x squared minus, remember, put the parentheses around the g of x, 1 minus x. If I distribute here, I get x squared minus 1 plus x, or in standard form, x squared plus x minus 1. So this would be my answer for f minus g of x. All right, let's try f times g of x. Notice there's no operation in between the f and the g, so we can understand that to be a multiplication dot there. So this is the same as saying I want f of x times g of x. So that would be x squared times 1 minus x. And if I distribute here, I would get x squared minus x cubed, or in standard form, negative 1x cubed plus x squared. So this is going to be my f times g of x. And how about dividing? If we have f divided by g of x, let me add that of x part here. So this is the same as f of x divided by g of x. So we would have x squared over 1 minus x. I really cannot simplify that at all, but we could talk about the domains for a moment. The domain for all of these functions so far has been all real numbers, but the domain for this one is going to be that x cannot equal 1. All right, what about if we did g of f of x? That would be 1 minus x over x squared, and here the domain would be that x cannot equal 0, because then we would be dividing by 0. All right, recall. If we have this function, 2x cubed minus 3x, you know that if I ask you to find f of dollar, you just plug in dollar wherever you see an x. That's right here and right here, so I would have $2 cubed minus $3. We could do the same thing with star, so that would be 2 star cubed minus 3 times star. All right, and if I had f of a plus b, that would be 2 times a plus b quantity cubed minus 3 times a plus b. All right, so you got to keep that in mind as we look at the next type of combinations of functions. So far we have been adding, subtracting, multiplying, and dividing functions. So this is the fifth way that we're going to be combining functions, and it is called composition. So it's another way of combining two functions. We can find the composition of one with another. Let's take a look at this example. If we have f of x equaling x squared and g of x equaling 1 minus x, then we can say what is f of g of x. Do I have that written somewhere? Maybe not. Okay, so I'm just going to say the way we read this is we say f of g of x. That's how we read that, f of g of x. And it's like a little circle. Instead of a multiplication dot, it's actually a little circle. in between the f and g. I think it's actually more easier to interpret it if you write it this way. All right, this still is read f of g of x, but I think you can see what's happening here, that we're actually plugging the g of x function into the f of x function. So in this case, I want f of, what was my g of x function? It was 1 minus x. So that's what I put in right here for the g of x, is 1 minus x. And now I'm going to plug in 1 minus x into the f function, where I see an x right here. So then I would have 1 minus x quantity squared. And if I use FOIL to multiply that out, I would have 1 minus x times 1 minus x. That's going to be 1 minus 2x plus x squared as my function f of g of x. All right, get rid of that last. Got it. F of g of x. Okay, and I could put that in standard form, but let's try it the other way. Let's try g of f of x. That's how we would read this. And this time we want to take the f function and plug it into the g function. So what was my f function? It was x squared. So if I want g of x squared, I'm going to take 1 minus, because I'm going to my g function, and I'm going to plug x squared in wherever I see an x. That's right here. So I'm going to have 1 minus x squared, because that's where my f of x would go in. And so my answer is just 1 minus x squared for g of f of x. All right. So let's take a look at some examples with actual numbers. So again, if my function was f of x equaling x squared, and g of x is equal to 1 minus x, then what would be the value of f of g of 3? Well, we have to evaluate g of 3 first. So what is g of 3? Let's do that off to the side here. G of 3 is 1 minus 3. That's a negative 2. That means g of 3 is actually equal to negative 2, which means I want to plug negative 2 into my f function. So I'm going to have f of negative 2. And I need to plug negative 2 in for x in the f function, so I get negative 2 quantity squared, and I get 4 as my answer. All right, how about if I wanted to find g of f of 3? Is that also going to be equal to 4? Well, let's find out. F of 3 we would need to evaluate first. Remember, we always work from inside out in math. So we want to find f of 3. I'm going to do that off to the side here. What is f of 3? Well, here's my f of x function. It's x squared. So I want 3 squared, which gives me 9. So if f of 3 is equal to 9, that means I really want g of 9. So now I need to go to my g function and plug in 9 where I see an x. So I'm going to have 1 minus 9 is negative 8. All right, I hope you're using good skills in watching this video. You're pausing, you're rewinding, rewatching as many times as you need to understand what we're talking about. All right. Okay, so our formal definition of the composition of two functions is this. The composition of the function f with the function g is given by f of g of x equaling f of g of x. And I'm just writing it. You could write it this way with that circle, or I prefer this way myself because it's easier to understand what's going on. We're going to plug the g of x function into the f function. Note that the domain of a composition function f of g of x is the set of all x in the domain of g such that g of x is in the domain of f. So you kind of have to watch that as you're determining domains. All right, let's do a few more examples here. If I have f of x equaling absolute value of x and g of x equaling x cubed minus 2, if I want to find f of g of x, I would want to find f of, what's my g of x function? What am I plugging in? That's the x cubed minus 2. And this means I want to plug x cubed minus 2 into the f function wherever I see an x. So I'm going to have that's equal to the absolute value of x cubed minus 2. And what if I wanted to find g of f of x? If I want g of f of x, okay, interesting color. If I want to find g of f of x, I would have g of absolute value of x. And that means I want to go to my g function and plug in absolute value of x wherever I see an x. So that's right here. So I would want absolute value of x, quantity cubed, minus 2. All right. And let's take a look at one last example with these same two functions, f and g. If I want to find f of g of negative 2, that means I want to find the g of negative 2 first. So kind of let's do that off to the side. G of negative 2 is going to be negative 2 quantity cubed minus 2, because I'm plugging in negative 2 wherever I see an x in the g function. So I want negative 2 quantity cubed minus 2. Negative 2 cubed, quantity cubed is negative 8. And minus 2 would give me negative 10. Well, that's good, but that's just this part of my answer. That's negative 10. So that means I really want to find f of negative 10. So I need to go to the f function and plug negative 10 in wherever I see an x. So I want absolute value of negative 10, which is equal to 10. So f of g of negative 2 would equal 10. Okay, so let's take a look at these problems. If f of x is square root of x and g of x is x squared plus 4, find the domain of f and g. All right, well, first of all, the domain here is going to be x is greater than or equal to 0. Okay, you could write it in inequality notation like that, or you could say, 0 comma positive infinity in interval notation. And g of x is x squared plus 4, so the domain here is all real numbers. All right, what if we want to find f of g of x? So that means we want to find f of x squared plus 4, okay, and that would be take that x squared plus 4 and plug it in wherever you see an x in the f function. So I'm going to plug x squared plus 4 in there. I take the x out and I replace it with x squared plus 4. Now what's the domain? Well, the domain for the g of x function was negative infinity to positive infinity, but now I have this square root, so I need to make sure that x squared plus 4 is greater than or equal to 0. And so I would get x squared is got to be greater than or equal to negative 4 if I subtract 4 from both sides. And that means my values, if I take the square root, I'm getting 2, let's see, hold up, x squared plus 4, well, that's always going to be positive, right? Because no matter what I plug in for x, even if I plug in negative 100, I'm squaring it and I'm getting a positive number. So I think our domain is going to be all real numbers for this particular problem. All right, and how about g of f of x? For g of f of x, we want to have g of square root of x. So I'm going to plug square root of x in wherever I see an x in the g function. So I'm going to have square root of x, quantity squared, plus 4. The square root of x is going in right here. And you know that the square root of x quantity squared, for this one, my x still has to be greater than or equal to 0 for my domain. Okay, because this squaring is on the outside, right, of the radical, which means I still can't plug in any positives, any negatives there. Okay, so we talked about the domains. All right, let's take a look at this example. H of x equals the cubed root of 8 minus x all over 5. Find two functions, f and g, such that f of g of x is equal to h of x. So this time we're going backwards. I'm giving you the composition function, and I'm asking you to find the two functions that could have been combined to make up that h of x function. All right, well, lots of different answers are possible here. One possible answer is that g of x was 8 minus x, for example. And the f of x function then would have been cube root of x over 5. If those are my answers, let's kind of see if I can prove this to you. If I try to do f of g of x with this function, that would say I want f of 8 minus x. And that's going to be cube root of 8 minus x all over 5, because I would take this 8 minus x expression and I would take out this x right here and I would plug that 8 minus x right in there. And that's how I would get back to my given function. Is that the only answer? Is this the only combination that we could come up with? No, you could come up with others. For example, you could say, slide all this. I kind of slide this all off to the side. This was one possible answer here, but another possible answer could be if I'm trying to come up with an f of x function and a g of x function, if I come up with that g of x is equal to cube root of 8 minus x, that might have been the inner function, and then my f of x function could have been x over 5. Let me see if I can prove that that would work for you. So if I do that, g of x is, I'm saying, cube root of 8 minus x. And if I want to plug that into the f function, that means I'm going to take out this x, and I'm going to replace it with this whole expression going in right there. So I'm going to have cube root of 8 minus x over 5. So you can see multiple answers are possible with this type of problem. Okay, there is a nice example on page 88 of your book, example 7. All right, and that example talks about bacteria in food, and it says the number n of bacteria in a refrigerated food is given by this function, capital N of t equaling 20 capital T squared minus 80 capital T plus 500, where capital T is between 2 and 14, and capital T is the temperature of the food in degrees Celsius. When the food is removed from refrigeration, I hope you're looking at this problem with me on page 88. When the food is removed from refrigeration, the temperature of the food is given by capital T of t equaling 4t plus 2, where t is between 0 and 3. All right? So capital T is the temperature of the food in degrees Celsius. And so what depends on what? Well, I would say that the temperature of the food depends on the number of bacteria, or is it the other way around? Well, I would think that you would tell me that the number of bacteria depends on the temperature. So that means that the temperature is the independent variable, and the number of bacteria would be the dependent variable. All right, and then this was the other expression that we just said, 4t plus 2. And that t is the time in hours since the food left refrigeration. So now we're comparing the time versus the temperature. And again, I would ask you, does the time depend on the temperature, or does the temperature depend on the time? Well, I think you would tell me it goes this way, that the temperature depends on the temperature of the food that's been left out, depends on the time, depends on how long it has been refrigerated. So that's why composition of functions can be used to make sense of this problem. And so if we want capital N of t, well, my capital T of t function is right here. So I'm going to plug in 4t plus 2 into the n function, n of 4 lowercase t plus 2. And that means I need to go back and plug that into my n function. And when I do that, I'm looking at my book to see the function. It will be 20 times 4t plus 2 quantity squared minus 80 times 4t plus 2, and I ran out of room here, but it's plus 500. That's if I plug in 4t plus 2 into my n of capital T function wherever I see a t. So I plugged in 4t plus 2 at those two locations. All right, and what does capital N of t represent? Well, remember, lowercase t was representing the time in hours, right? Capital T, this is representing time. This capital T was representing temperature. And this capital N was representing the number of bacteria. So the one function gave us the temperature, the number of bacteria based on the temperature of the food, and the other function gave us the temperature of the food based on the time it's been out. So capital N of capital T of T would represent the number of bacteria given the time the food has been out of refrigeration. All right. Okay, so you can then find the time when the bacterial count reaches 1500. How would you do that? Well, to find the time when the bacterial count reaches 1500, we would plug in 1500 for the bacteria count. So in this case, I'm going back up to this equation here, I would say 1500 equals, and I would have to set it equal to all of this, and then solve the equation. All right, but I will let you do that, or you can take a look at how they did this in the book. All right. Actually, I guess their question was 2000. I made up 1500, but you can see how they did the answer for 2000. Okay, I do want to take a look at number 1 in the exercises. So if you could take a look at page 89 in your book. And here's the sketch for f and g. So this function right here is the f function. And this function here is the g function. I did the best I could with that graph. I'm trying to model what they have there. And that's not too bad. And then you are asked to use the graph to graph f plus g of x. All right. And so in this case, if I want to do f plus g of x, I could just add this height here with this height. So that's a height of 2 and a height of -1. Well, that's going to add up to this height right here of 1. 2 plus -1 gives me 1. What if I was adding this height of 2 and this height of 0? Well, when I add those, I do get a height of 2. So I can connect those so far. And if I add a height of 1 here plus a height of 1/2 is what it looks like to me, then we would have 1.5. So I can now connect like this. And then again, I have a height of 0 and a height of 2. So I can combine those and again get a height of 2. So this graph here would be our combination f plus g of x. That would be the graph for that. Let's see. If I want to look at number 18. No, I think the one that I want to look at is here for 44A and 45B on page 90. Let's take a look at 44A. So it's saying what's f minus g of 1? So 44A is saying what's f minus g of 1? Well, let me remind you that means f of 1 minus g of 1. So I need to find my f of 1. If this is my f of 1 function here, then here's 1, and so my f of 1 is this height right here, which is 2. So f of 1 equals 2. And then over here, on my g function, what's g of 1? Well, here's 1, and so my g function, g of 1, is up here at a height of 3, right? And so g of 1 is equal to 3, and when I subtract those, I get 2 minus 3 gives me a -1. So my answer for problem 44A would be -1. All right, what about 45B? For 45B, it's saying what's g of f of 2? So what's g? Let me clear all this out. Okay, what is g of f of 2? This is for 45B. And so if I want Oh boy, that's not what I wanted to happen. Okay, so if I want g of f of 2, that means I want to find f of 2 first. So let's kind of do that off to the side. What's f of 2? Well, here's 2 on my f function. Looks like it's a height of 0. F of 2 is equal to 0. So that means I really want to find g of 0. So now I have to look at my g function. Here's 0 for my g function. Sure looks like it's a height of 4 on the g function. That g of 0 is equal to 4. So that means that g of f of 2 is equal to 4. All right, that's it for this lesson. You know that you will have a quiz to take and some other things to do. And thanks for watching.